In this video, we'll briefly introduce the polar coordinate system. Up first, just a very brief review of the rectangular system. Most of you are familiar with the rectangular coordinate system, in which a point looks like x, y. We have an x-axis, a y-axis, and the point in the middle known as the origin. When we plot a point, say 2, 3, we start at the origin, and in this case, we would go to the right 2 units, and then we would go up 1, 2, 3 units to plot that point 2, 3. In the rectangular system, we're always moving up, down, left, or right to plot a point. And after plotting points, you learned all about graphing multiple different kinds of equations or functions. Sometimes, though, there are better ways to graph things using the polar coordinate system. The point is going to look similar to the rectangular system because we have two coordinates, r, theta, but it's not xy coordinates. R is going to be a distance from the pole, which is basically the origin, and then theta is an angle that is swept out, starting at the polar axis. So be careful. Notice that the coordinates will look similar, but they do mean very different things. Here I have the polar axis, which is essentially the positive x-axis. I've overlaid it on top of the xy system so you can see how similar it is. And we also have the pole, which is, again, essentially it's the origin of the rectangular coordinate system. Now in the polar system, typically the xy axes are not there. We're going to have a pole and the polar axis. Up next, we're going to look at how to plot these points on the polar system. Remember that r theta is what a coordinate looks like. We'll typically start with theta and draw out the angle theta, starting from the polar axis and sweeping it out whatever radians or degrees we're told, and then measure the distance r from the pole. Recognize that if r is negative, we're going to travel in the opposite direction of the terminal side of that angle. We'll look at several different points to plot. Remember that these are given to you in terms of r theta, not x and y. R is the distance from the pole, and theta is the angle that is swept out. Now I'm going to be drawing several different lines as I go through each of these examples, but then I'm going to erase them. Otherwise, this will get incredibly messy. So if you're one of my students and you're watching these videos, I recommend that you don't draw all the lines that I'm going to draw unless you want to erase them. Maybe watch this video through to the end and go from there. Up first, we have 3 pi thirds. Again, we're thinking about the origin as the pole, and then the positive x-axis is your polar axis. Start by sweeping out the angle pi thirds. So from the polar axis, we're going to sweep out the angle pi thirds. And then that's our terminal side. Where the angle stops is our terminal side. Now, the distance from the pole has to be 3 units. So we're going from the pole 1, 2, 3 units away. This point is point A. Up next, we have negative 5 pi 6. Start at the polar axis, and we'll sweep out an angle of 5 pi 6. So this stops at 5 pi 6. That is the terminal side of the angle. But notice that your r is negative 5. So we don't want to count out 5 in this direction. We're going to go to the opposite side of the terminal side, which is down here. And we're going to count out 5 units. 1, 2, 3, 4, and 5. This is point B. Part C, we have 4 negative pi halves. Notice that that angle is negative. Starting at the polar axis, since the angle is negative, we're going to move clockwise and get to negative pi halves. Remember that 3 pi halves is the same as negative pi halves. And we want r to be 4. So we're counting 1, 2, 3, 4 units away from the pole. This is point C. Part D, we have negative 6 pi. Again, starting at the polar axis. We'll sweep that angle out, pi radians, to get to the terminal side. R is negative 6. So starting at the terminal side, we want to go in the opposite direction. 1, 2, 3, 4, 5, 6 units away. Here we have our point D. E is 2, 5 pi fourths. Again, starting on the polar axis, we will sweep out 5 pi fourths. This is the terminal side. And we're looking for R to be 2. So that's 1, 2 on the terminal side. We have our point E. F is negative 3, 2 pi thirds. Starting on the polar axis, we will sweep out to 2 pi thirds. This is our terminal side. R is negative 3, so we want to come to the opposite side of that terminal side, down here, and we're looking for 3 units. 1, 2, 3. This is point F. And finally, part G. We want to plot 3 negative pi thirds. Starting on the polar axis, we will sweep out the angle clockwise since we have a negative angle to pi thirds. Remember that 5 pi thirds is negative pi thirds. And we're moving, R is 3. So we have 1, 2, 3. Looks like it's the same point as F. And part H, what do you notice about F and G? It's the same point. They represent the same point. Back in the rectangular coordinate system, every point has a unique location, an x and a y coordinate. Whereas in the polar coordinates, for example here, we've represented this point 2 different ways. In fact, there's an infinite number of ways to represent this point in the polar coordinate system. Every point in the polar coordinate system can be written an infinite number of different ways, and we'll investigate this in the next video.